Hi guys, my computer's being really flaky this morning. So if I freeze, I may already be frozen. Can y'all hear me? Okay. Dion, can you hear me? Tiara, you can hear me. Look at you grinning. Tiara, can you hear me? I'm not asking Dion anymore.
Yes.
I've been freezing all morning. Okay, who I got now? I got Dion, I got Tiara, I got Alexis. I don't have Deborah. Guys, that quiz I just sent you, we're going to go over it because I swear I think I graded things. We're going to look at how to do that stuff, okay? Because there's a couple of errors people made, and then I caught it. Dion, I should have sent you one 3 times because I kept seeing things. But anyway, just everybody gets a 10. Let's just go over it, okay? Let's see what we got here. Okay, let's do that first. And now somebody disappeared. Who disappeared? Alexis disappeared. Deborah's still not here. All right, hang on. And I've frozen. Okay. All right, guys, let me bring the screen. Let me bring what I want up and we'll start talking and maybe I can get everybody else in a second. I don't know where Alexis went. She must be having problems again. And I don't have Deborah, but Tiara and Dion, and look, and Dion, you did, the one I really want to look at is 1B, okay? But if you look at, let's look at 1A too, because I think Tiara, you made a mistake in that one with the negative. If you want it in geometric series form, so we're gonna, okay, there's somebody else trying to come in. Hang on, it's Alexis again. In and out.
Oh,
Oh, you got it now, Alexis? Okay. Okay, I think she's there. Okay.
Yeah, my computer, like I was waiting before class, but I guess my computer's acting stupid.
No,
so.
I was late because I couldn't get in because my email, my calendar wouldn't come up. I don't know what's going on today. Anyway, I want to go over this quiz, that power series representation. I've not gotten to the Maclaurin series one yet, but I want to go over this one because after I started looking at things again, I didn't make a very good key, and I don't know what I wrote. All right, so this first one was 2 over 3 plus x. We got to put it in geometric series form. I'll divide everything by 3. That's easy enough. The problem here is I've got a plus. I'm going to write that as minus a minus. That makes a equal 2/3. It makes r equal minus x over 3. Tiara, you're looking at absolute value before you need to. This is the r you need in your series right here. Okay, if you see that, a minus on that, you're going to have a -1 to the nth on your stuff. Okay, so you need to make sure you do that. And then when you put it in absolute value, it'll be x and you'll multiply by 3. So what the series looked like on that one was the 2/3, and you can bring it in or out, and then it would be minus x over 3 to the nth. That's your r. If you want to, which I kind of like it to do this, is write the minus as a -1 to the nth, and then write x over 3 to the nth.
I have that.
Is that what you had? Okay, like I said, everybody's going to get a 10 because I messed up. I don't know. You got the minus in there? Maybe I didn't see it. I don't know.
Yeah, the minus is on the x over 3. I didn't pull it out like you just did.
Oh, okay. All right. I tried to do them in a real big hurry between 12:30 and 1, and it just, I was making all kind. When I got to Dion's paper, I had to send it to her 3 times. I was just like, okay, I don't even know what I graded. But does everybody see that one? This is the one there was a problem on. And what some of you ended up having was something like this: minus x minus 2. Now, I want to tell you that that's not about c equal 2 right there. what you need is an x minus 2, not a minus x minus 2. And as a matter of fact, if you pulled the minus out of that and put minus a minus, it would have been x plus 2, and that would have meant c was minus 2. So long story short, you got to be careful with the signs here. Now, Dion, let me show you the way Dion did it, and it's probably a better approach to this than to fiddle around too much with the negatives. If you look at this and you say, well, I need an x minus 2 there, okay? Don't worry about the plus yet. I need an x minus 2 there. And if I had to add a minus 2 there, I'd have to add a plus 2 over here somewhere just to balance things out, okay? So when we do that, we'll get 2 over 5 plus x minus 2. And you can see it's the same. It's easy. 5 minus 2 is 3 there. And now what you want to do is now take care of that plus sign. I'll write that now as 2 over 5 minus a minus x minus 2. It's like you're right. Remember how you wrote minus a minus x up here? Same thing here. Minus a minus x minus 2. Now it is over that. I'm going to erase. So some of you did this, and if you see that's a problem, okay? Because it's got to be, you don't need that minus right there. All right, let's finish it out. So what I wind up with here, guys, if I divide by 5, that'll be 2/5, 1 minus a minus x minus 2. That's kind of the way you need to look at it. Then your a is 2/5. And on yours, when I looked at it again, Dion, I thought I saw a 4 up there, and I wasn't sure where the 4 came from. I don't think there's another place for that to get. The 2 suddenly changed to a 4. Okay. I can't unmute. I can't.
When I was doing it, I was looking at an example, and I think that I was looking at the number just in there.
Okay. All right. But you understand it's a 2. Okay. So anyway, there's that. Now here's what it looks like. A is 2/5. Now R is minus x minus 2. That means the absolute value of R is just going to say x minus 2 is in between. I'm sorry, you got to put this over 5 too. Sorry, that's all over 5 because I divided everything by 5 here. So that's that. All right, it's minus 2 over 5. And then when you put that between 1 and minus 1, then it plays out, multiply by 5. And I think it was between 7 and minus 3. So x ended up being between 7 and minus 3. But what the series looks like is this. It's going to have, let me carve out some room here. It's going to have a sum. You can put the 2/5 out here if you want to. Then it's going to be, I've got a minus with that, so I'm going to write it as minus 1 to the nth, and then the rest of it, x minus 2 over 5, will also be to the nth. That's hard to see, but I'm just being sloppy, but I'm running out of room here. X minus 2 to the nth. And if you wanted to, you could put that as x minus 2 to the nth over 5 to the nth. But those of you had a minus here on the x, you can't do that. You've got to get it looking exactly right there. Does that make sense? That was the only one that I saw some funky stuff going on there.
Like, I just don't understand. Like, I think what I did, I subtracted 2 from each one. Because I was like, well, it needs an x minus 2. So
okay. All right.
I subtracted 2, and then I subtracted 2 from the 3.
All right. So tell me it started out as 2 over 3 plus x. Tell me what you did first, Alexis. Let me see if I can see where you're thinking wrong.
First, I went ahead and said the minus x because I saw they were adding.
Yeah, you don't want to do that if you only want to do that unless if C is 0.
Okay.
If C is something else, you got to create that something else first and then do the minus thing. So here's what I meant. So that's what I said a minute ago. I need this to be an x minus 2, okay? So if I take away 2 there and add 2 here, it's balanced. So I've got 2 over 5 plus x minus 2. Now deal with your minus. So it's 2 over 5 minus a minus x minus 2. It makes it really sort of messy. Normally we would have just put minus or minus x, but this was about c equal 2. So dividing by 5, dividing all that stuff by 5, now you know what a is. That's 1, that's what we need there. And then this is your r. You got to have this x minus 2 in parentheses just like that. Okay? So you really don't want to mess with the plus until you get this part right.
I don't really understand like the plus and minus thing, because that's where like I got to that point, except for my number, I said minus 1, like 1 minus the negative x minus 2.
Okay, that's wrong. Okay, and I'll tell you why. That's what most everybody did. Did yours look like this? Did yours look like that?
Is that a parentheses or is that a 1?
Yes, it's a parentheses.
Okay.
Yeah,
that's how mine looked.
Okay, that's not right. It's got to look like x minus 2. And you might say, well, I can make it look like that, but you really can't, because when you pull out a negative there, let's pull out a negative there, I'd have x plus 2. And that would mean that this series was around minus 2, not 2.
I just don't.
You cannot have a minus right there. If it's around x minus 2, you've got to have it in powers of x minus 2. So you just can't do that. You've got to leave this as a coefficient of 1 on that thing. So whatever you have to do. But if you did this, it's not around x minus 2, because if I pulled a negative out, it would change both of these signs, and that would be an x plus 2. And then it would be minus a minus 2. If you did that, you would have been writing it around minus 2, not 2.
And what about the 1? Like, I don't know. I think I just did this whole problem wrong. Because when it said, like, it needed to be around about c equals 2, I was like, well, I need an x minus 2. So I subtracted 2 from the 3 as well.
Okay, and that's what you're supposed to do. Let me just start. Let me start again, because this is kind of messy. But let me show you what I did again. Now try to follow me one step at a time. What y'all did was write it. You had an extra negative in there that you shouldn't need. So the first thing I did was at this. The original problem looked like. Did it look like that? No, it looked like this.
You had a 3.
That, yeah. It looked like that. Dang it. I can't get it to right. It looked like that. Okay? You need it in powers of x minus 2. Now, whatever you do, you leave that alone for right now, because you've got that, but you got to make changes to compensate for that, okay? So you understand that would be about x minus 2. It's x minus c is what it should be, okay? So because you subtracted a 2 there, you're going to have to add a 2 onto that. The net result is still x plus 3. So in getting that right, I had to make a change somewhere else to balance it. You guys are chemistry majors. You know how to balance equations. That's what you're doing there. You're making things look different, but they are the same. So now what I've got is 2 over 5 plus x minus 2. And there are only 2 things left that are wrong with it. Number 1, I need a 1 right there. Okay? So now you've been doing this right. I'm going to divide. I'm doing a little different order, but you can divide every one of these things by 5. So that's my next step. So it'll be 2/5, 1 plus x minus 2. It almost looks right. And again, you do not want to mess this up, but you can change things in front of it. Tell me this, Alexis, what did you do when you had 2 over 1 plus x? What did you write it as?
2 over 1 plus x?
Yeah, you wrote it as 1.
I wrote it plus x.
1 plus x, but then you wrote that as 1 minus a minus x, right?
Yeah, it's just like my phone's at the bottom of the screen. So
okay.
Okay, yeah.
Sorry. Okay. The reason that works, guys, and what you did doesn't work is because minus x minus 0 is minus x. So it is about 0 if you pull a negative out of it, but it didn't work with 2. So what I'm going to do in this other one is this. All right, I'm going to say, you know what? I don't want that minus sign there. I mean, I don't want that plus sign there. I want a minus. So I'm going to write it like this. 2/5, 1 minus, I'll put a bracket, a minus x minus 2. Okay. Notice I did not disturb the integrity of this x minus 2. It's still an x minus 2, but now you can see, oh, this is going to be an alternating thing because that minus is going to go in there on the power. And I needed to divide everything by 5, so I didn't do that at that point. So I'm going to see, I divided that one by 5, and I need to also divide this one by 5. But I was focused on getting that right. So now my A is 2/5. My R is x minus 2 over 5 with a minus on it because it's all of the stuff in here, right? And then I know that the absolute value of R for it to converge has to be less than 1. Okay, and then we're okay with that. And then when you take the absolute value, see the absolute value of a minus will just leave this thing as just an x minus 2. So you end up with x minus 2 over 5 between 1 and minus 1, and then you carry it out. Let's do another one. Let's do another one and see what happens. I don't know what's going to happen. We'll see what goes on here. Suppose I had 7 over 3 plus x, and I wanted to do it around c equal minus 4. So guys, if I'm doing it around c equal minus 4, I've got to have something that looks like x minus a minus 4. In other words, my power series has those things in there. So it's got to look like x plus 4. If it were around positive 4, it would need to look like x minus 4. So here's what I'm going to do with that one. I need an x plus 4 there. But I can't just arbitrarily add a plus 4 there. What do I have to take away to balance this thing?
4.
If I added a 4, I'm going to have to take away a 4, okay? See, I added a 4 because I wanted it to be about c equal minus 4. See, this is in the form x minus c, where c is minus 4. So if I add a 4 there to get closer to what I want, I need to take away a 4 in the same string there. So my next step, 7 over minus 1 plus x plus 4. That's what I want. It's x minus a minus 4. It's in powers of x minus c, where c is minus 4. But I still have this plus sign right here. So now I'm gonna, well, actually, I need to do what here first? And this is how you can figure out what you need or what you don't need. What do I need to divide by here to get this to work out right?
-1.
-1. So if I divide by -1, the top one will be a -7. -1 over -1 is 1. And actually, if I divide this other one by negative, things actually coming out nice for me. I just popped this one off the top of my head because I had to divide everything by a negative. It changed that sign right there. And I needed that sign change because now it looks like a geometric series. What's A in this geometric series? It's -7. Yep. And my R is x minus a minus 4, or x plus 4. So if A is -7, my R is x minus a minus 4, or plus 4 if you want to. My series looks like this: -7, x minus 4 minus a minus 4, which is x plus 4 to the nth power. Nth power. I'm creating 4s like Dion here. I don't know what happened there. It's like, that's an n. Okay. So that's, you create this part first, and it's x minus whatever you're writing it about. If I'm writing it about 10, it'll be x minus 10. If I'm writing it about 6, it'll be x plus 6, because that's x, well, if I'm writing it about -6, x minus a minus 6, the x plus 6. Okay. I'll look at the Taylor series stuff later. Well, tonight. I'll get it back to you. I'll get it back to you before tomorrow, and we'll talk about that if we need to. The rest of this we went over yesterday. What a couple of you forgot to do was when you got that inverse tangent thing, that x times the inverse tangent, you kind of so excited about finding the series, you forgot to integrate it. Got to integrate it, okay. That's Terry, you weren't the only one that did that, actually. I think somebody else did that. Anyway. Okay, anybody else? All right, let's go back, and get your calculator if you don't have it, because we're gonna play a little with the calculator today. You had some homework problems that were converting things from polar to rectangular. I want to know, first of all, if you had any issues with those, and there weren't very many of them, guys, those few homework problems I gave that said, convert this to polar or convert this to rectangular. Did anybody have any trouble with any of those? Anybody? That was stuff on page 667. Just a few problems like 27, 29, and 31, I think, and then maybe 37, 39, and that was about it. 49 maybe, 49. Anybody problems with any of that? Your basic ideas are those things where r equal x cosine theta, and x equal r cosine theta, and so forth. What I want to do today is I want to graph one of these things by hand. Now, lest you get frustrated here, we're not going to graph many of them by hand because it's a pain in the butt. And you need your unit circle close by so you can write all the things you know about your unit circle. Put this down here. So I'm going to move, let's go over here a little bit. I'm going to graph r equal 2 plus 2 cosine theta, just to show you how to plot a few more points and do the thing. And then we're going to go mostly to graphing these things on the calculator. Okay, so we'll do more on we'll play with it on the calculator today too. If I say, I'm going to start with my theta, and I'm going to start plugging in some thetas, and I'm going to see what the value of this function is. Now, guys, this is, for purposes of something I'll do later, this is an f of theta. R is a function of theta. So what I'm getting here is I'm plugging in the theta, and I'm getting the r. So let's just look at a couple things here, guys. And I'm just tripping around the unit circle right here. If I say the angle is 0, the cosine of 0 is 1, so 2 plus 2 is 4, okay? As I do this, I'm going to plot these points on this graph I've got down here. Now, why I put it way down there, I have no idea. But anyway, I'm going to plot the point 0, 4 in polar coordinates. Now, what the point 0, 4 is, remember, is that means not 0, 4, but 4. Go back here just a second. R was 4 and theta was 0. So it's 4, 0 that I'm plotting. Remember we plot the points r, comma, theta. So if I'm plotting the point 4, 0, it's on this axis where the angle is 0, and it goes out 1, 2, 3, 4 right there. So there's the first point I've got right there. Okay. If you've got some of that paper close by, you might want to do this, but you may not have any. All right, look at the next one. I'm tripping around the unit circle again. What if cosine is pi over 6? Well, that's root 3 over 2. If you look at your unit circle, cosine of pi over 6 is root 3 over 2. So that value, and I'm going to check my values here, is 2 plus root 3. And I got 3.73. So the point I'm going to plot there is 3.73. That's my r. And my theta's pi over 6. So I'm going to go down here and do that. Pi over 6, if I look at this thing right here, 1, 2, 3, 4, 5, 6. This is divided, this is like pi over 12s, I think. 1 pi over 12, 2 pi over 12, 3 pi over 12. So this one right here is the pi over 6. This is the pi over 4. This is the pi over 3. And this is pi over 2. So I'll do that while I'm playing with it. Okay. So I'm going to plot the point 3.73 pi over 6. Well, 3.73, there's pi over 6 right there. 1, 2, 3. It's a little back right here. It's right before you get to the fourth circle. So 1, 2, 3.73 is about that much. Okay, I'm going to plot the points, then I'm going to play connect the dots with these things. Is everybody okay with the way I'm plotting points now that you kind of looked at this? Okay. And go back. If I look at pi over 3, the cosine of pi over 3, that's the x value there, is a half. So 2 plus 2 times a half is 2 plus 1 is 3. So when I get to pi over 3, the point is 3. Okay, so pi over 3, I go out 3 on the circle, and at pi over 3, I'll be right there. So 1, 2, 3, out 3, and at the angle, pi over 3. All right, everybody with me? Just plot.
So my question is, like, on the test, like when we be doing this,
no, well, here's what I suspect. What I suspect is that I will ask you just to plot a few points by hand, so I know you know how to plot points. But if I ask you to plot the whole curve, we will probably use the calculator. Okay, I'm just doing this to show you what happens. Okay, that's the way I'm doing it. All right. Okay, so let's try another one. Let's go to pi over 2. That's the next nice place. If I let theta be pi over 2, I'll get 2 plus the cosine of pi over 2, but the cosine of pi over 2 is 0, so 2 plus 0 is 2. So the point I'm plotting there is 2 pi over 2. Go back. So I'm on the circle 2, and I'm up at pi 1, 2. I'm up at pi over 2. All right. I'm up at pi over 2. So guys, if I were to play connect the dots with this thing right now, it would go there, it would start going there. Okay? So it's got this curve to it. Okay? Let's go back and look at another one. This is really tedious if you do it by hand. Rectangular coordinates aren't so bad. Polar coordinates can be pretty bad. Okay, let's go to 2 pi over 3. All right, 2 pi over 3. If I put in 2 pi over 3, the cosine of 2 pi over 3 is actually negative. And at 2 pi over 3, I think it is root 3 over 2. Is that right? Cosine of 2 pi over 3? Or is it 1/2? What's that? What's on the unit circle there? It's like draw my unit circle here. So if I'm looking at pi over 3, for example, it has a point that is 1/2 root 3 over 2. And 2 pi over 3 is going to be minus 1/2 root 3 over 2. Okay, so the cosine will be minus 1/2. So when I put that in there, minus 1/2 times 2 will be minus 1. So 2 minus 1 will be 1. So the next point I've got is at 2 pi over 3. It's 1. All right, so I'm going to plot it. Again, these are in increments of 15 degrees. So 15, 30, 45, 60, 75, 90, 90, that'd be 105, and then the 2 pi over 3 is going to be right here. Okay. So the value, that point there was 1, 2 pi over 3. So interesting here, right there, I go out on the circle only on the one circle, the one that's 1 unit away, and I got on that angle right there, I've got on that angle right there, I got this point. So if I keep extending here, I get that. Okay. All right, let's go another one.
I know the shape.
I bet you do. What do you think it is? I've already done it one time. What have I done? What do you think?
It's a circle.
It's not a circle. It's not.
No. I got it. It's a heart.
It's a heart. What do you call it? What's the technical name for it?
Cardiac.
No.
Cardioid.
It's a cardioid, okay? It's a cardioid. But it's got that word root in it. It's got C-A-R-D in it. Okay, let's go a couple more, and then I'm going to show you something that's going to help us a lot. Wow. If I put in pi, I'll have 2 plus 2 times the cosine of pi. Well, cosine of pi is -1. I get 0. Oh, so that means when I get around to pi, I don't go anywhere. I'm right at the origin. I don't go anywhere. That means it flips around to there. Now that's how I know it's not a circle right now, because it's got that kind of kink in it. I said, let's do one more point, and then I want to show you something interesting that knowing some trig will help you with. If I said 5 pi over 4, let's see what I've got here. If I said 5 pi over 4, I didn't do any pi over 4s, but that's minus root 2 over 2. And that'll be 1 minus root 2. I think I computed that wrong. No, the cosine, I think I computed that one wrong. Let's try this again. Guys, let me try that. That's I think I may have computed the rest of those wrong. But anyway, it's 5 pi over 4. We said that was minus root 2 over 2. So the 2's will cancel, so it's 2 minus root 2. Okay, so when I get 2 minus root 2, I do wind up with 0.58. Okay, maybe I got it right. Okay. But let's see where we are. 0.58, right inside the 1 circle. Or about 0.59, we'll say. So 5 pi over 4 is down here. It splits the quadrant. It's right there. So when I'm there, it says I'm at 0.59. Well, that's not even to the 1 circle, so I'm about right there maybe. Okay, and then you can tell what it's going to do. When I do the rest of these points, it's going to flip it around. But there's also, you know how we talk about symmetry? Things look the same on one side of the axis as the other. Let me remind you something from trig. Do you guys know an identity for the cosine of minus theta and how it relates to the cosine of theta? What's the cosine of minus theta?
I might be wrong.
Well, I don't care if you're wrong. Tell me what you think. I'll let you know if you're wrong. What? What's cosine of minus theta?
Never mind.
Is it the inverse?
No. Let me ask you this. If I had a point, remember this. If I had a point xy here, what would the cosine be? If that was on the unit circle, what would the x be? Which is the cosine and which is the sine, guys?
The x is the cosine.
You got it. The x is the cosine. Now, if I go down here and go the same amount, but I do minus theta, because I'm going in that direction, tell me what that point is. What's that point right there? If you go straight across, what's its x coordinate?
I don't know.
Well,
minus x?
It's the same. No, actually, if you go straight across, say that's the point 2, 3. That would be the point 2 minus 3. So if you go across the x-axis, the x stays the same. What is it that changes, guys?
Oh, yeah, the y.
The y.
So it turns out that the cosine of minus theta is the same as the cosine of theta. If that happens, what? Is that what you said?
That don't make any sense. I thought you were going to say sine or something. Not the same thing.
So wait, so is sine the one where it's like negative sine?
Yes.
Well,
yeah.
So I knew it. Okay.
Yeah, right. If it's sine, it's going to change sign. So in other words, if you this identity for sine, it's the opposite. It's minus sine theta.
Oh, we did learn these. These are we did learn them.
I know you learned those identities. But here's the beauty of this when you're doing polar coordinates. If I can look at what I was trying to graph, guys. I was trying to graph r equal 2 plus 2 cosine theta, and it says that if I put in a negative theta here, I would get the same thing because I know that cosine theta and cosine negative theta are the same, right? By that identity I just talked about. That's a symmetry test. And what it basically says is if you see that, you're just going to get this thing copied on the other side.
Is it the same for sine?
What's that?
Like sine does that too.
If it's a sine, hey, listen, let me let you guess. And then we'll play with the calculator, okay? If I said, because the cosine of theta is the same as the cosine of minus theta, and it's symmetric about the polar axis right here, I mean, that axis right there, if I have a sine and it's opposite, maybe it has a different kind of symmetry. In other words, maybe it's not symmetric around this one. It might be symmetric around what?
The other side.
Around the other one. Let's play with it. Let me bring my calculator up, guys. You get your calculators ready to go, and let me bring my calculator. But anyway, that's how I would do it by hand, and it's a real pain. But I want to show you some of the things that happen with this stuff when we're playing with a calculator. So let's see if I can.
Why do people use this? Like, I don't understand.
Man, this stuff is really important because it's you can plot curves that are almost impossible to plot in rectangular coordinates because you know what, in Earth, in space, things don't happen in straight lines usually. They happen in big old curves and all kinds of things. So these facilitate or make easier different kinds of things that you'd want to do. I'll see.
Like, who made this up? Because I don't really like it.
Scientists made it up, just like you want to be. Scientists made it up because it looked easier to graph things with it. Okay. I like this. Let's just play with it on the calculator. Let's see how it works out on the calculator.
I want to see if it's on here on my tapestry. Yeah, they got a little circle on here with all these circles.
I'm gonna go with new share and see what I can find. Y'all tell me when you see it, okay? And then I'm gonna play with it.
Yeah.
Can you? I'm up. Okay, good. All right. This is what I'm doing in differential equations. I'm doing springs, and that's what a spring does. It goes up and down and up and down and up and down. However, I'm not doing springs in this class. I'm doing polar coordinates. So what I'm gonna do first is change my mode, and I'm gonna go down and change my mode from a functional mode, i.e. x's and y's, to a polar mode. Okay, I need to get rid of this down here. Move it over a little bit. And that polar mode, I gotta enter it. There we go. Ugh. Okay. No. This thing is in my way. Totally in my way. Let me get rid of it. Okay, there we go. Okay, so I'm going to enter polar mode here. Okay. All right, is everybody in polar mode? What's what we need here? All right, I'm going to put in that one I just did. I'm going to hit y equal, and now it's in polar form. So let's look at 3 cosine theta. And imagine yourself, whoops, let's just don't look at that. Let me clear that for a minute. I'm going to look at 3 cosine theta, and you pick up the theta the same place you pick up the x. All right, and I'm going to look at my window, and I'm going to let my window go from 0 to 2 pi, just because a lot of times these happen in 2 pi units, because that's how long it takes to get around the unit circle, unless you double your angle, and then we'll worry about that later. So I'm going to go second pi here. Nah, I said I was going to do 2 pi, didn't I? Let me clear that. I'm going to do 2 pi. So 2 pi. Okay, I'm going to leave that step the same. That's a step of 0.3 radians, 0.13 radians, guys, and it's the default setting. As with rectangular coordinates, default setting is usually 1. I'm going to go with my x min and x max. I think that I will go from -5 to 5. Let me try that. So -5. You have to play with it. I kind of know what's going to happen here. So, and so on the X scale is 1, Y min and Y max, I'm gonna also do -5. So I want a 5 by 5 screen here. Okay.
Mine was about 10.
Well, yours might be on 10, but I know something that's gonna happen with this graph, and it'd be too little if I put it at 10. All right, there's a graph. Guys, remember I said these things don't come out looking quite right because your screen is longer than it is wide, so the pixels are out of whack. So if you want to get this looking good, go to Zoom Square. It'll square up the screen so the pixels are the same up and down. Well, said it would. Zoom Square, and you can just hit the number Zoom 5 if you want to, and then hit enter. And see, it squared it up. It's a circle. Guys, that thing had a cosine in it. Notice the top half right here is the same as the bottom half right there. It got shifted. For whatever reason, it got shifted. So the next thing I want to do is look at what it would look like if I put a sign in it. And I'm going to leave that one there so we can see both of them. So I'm going to leave that one, and I'm going to put 3, and then I'm going to do sine theta. All right, so I'll pick up my theta. I'll close it. I think my window is going to be fine. I'm going to graph it. Notice what you got for sine theta. Sine theta is also a circle with a radius of 3, or 3 sine theta is a radius of 3. But notice it is symmetric about the y-axis, because if you go across the y-axis, y's remain the same. When you went across the x-axis, x's remain the same. So you got symmetry with cosines here. You got symmetry with sines here.
Was it 3 sine theta?
It was 3, and actually that made the radius 3. You don't see the circles on this. That's unfortunate, but you see you're on a circle of radius. Well, the radius 1.5. Sorry, if you leave, starts at 0 and it goes out to 3. The radius is actually 1.5. Let's do the cardioid. Let's do the cardioid for a minute. Well, the cardioid. Let me clear that one, and I'll clear the other one too. The cardioid we had was it. What was it, guys? 2 plus 2 cosine theta, I think is what we had. So 2 plus 2 cosine theta. And then we'll close it. And then I'm going to go down and I'm going to put in 2 plus 2 sine theta. All right, so 2 plus 2 sine theta. We'll just do both of them on the same graph if you can tell what's going on. And then I'm going to graph it. First one's the cosine, second was the sine. Notice how the symmetry changed there, guys.
Oh, I don't like that.
All right, let me show you something else.
Looks like a peach.
It does look like a peach if you look at the whole thing, or it looks like an apple. If I could draw like a stem right there, I could get an apple sort of. Anyway, so that's 2 cardioids. What do you think is going to happen if I change the sign in it? Keep an eye on what that one looks like. Instead of having plus, let's put a minus in this one. And I'll do the same in this one. Whoops. Actually, I'll put a minus in that one too. We'll see if we can remember what the other one looked like. If I graph it, it sort of shifted it around a little bit. It flipped it actually. Well, it didn't flip it. It probably should have just left one on there. But anyway, it moved it. So if you've got something that looks like a number plus that same number times a cosine or a sine, you're going to get a cardioid. All right, let's play a little more.
Wait, which one's the sine?
The one that with the sine was the one that was symmetric with respect to the y-axis. The sine was the red one, okay? So, and the other one was the cosine. Suppose I had this one. Suppose I did this. I'm gonna delete the next one so we can just look at one thing at a time. I'm gonna go back up here, and I am going to change I'm not gonna make these numbers the same anymore. I'm gonna make this second number 4. Okay? And in other words, the 2 aren't the same. Guys, if those 2 numbers are the same with a plus or a minus and a sine or a cosine, it's a cardioid. Look at that. That's not quite a cardioid. What did it do?
It made a swirl.
It made a circle in it. When I started, if I start at 0, you get 0, it comes around, it flips around and gets right back to there. Okay. Now I'm going to put something on top of that. I'm going to put R equal 3 on top of that. And you ought to know what R equal 3 is. That just means everywhere you're 3 units away from the origin. So R equal 3 is the equation of a circle centered at the origin. So if I graph that, I'll get that. Okay, so the circular radius 3. This is called a limaçon. Lima bean is the word root there. In calculus, what we're going to want to do, and we'll play with this some. We need to focus on the series test for a little while, maybe tomorrow. But we may want to find some area here. What if we want to find the area of this moon-shaped thing right here? I would need to know how to find points of intersection, and boy, I don't think I want to make rectangles in this, because rectangles are set up for area in rectangular coordinate systems, okay? This is not going to lend itself to rectangles because they'll be hard to work with. Couple more things to play with, guys. And I want you to see if you can notice the difference here. I'm going to put in this 3 sine, whoa, that's not what I want to do. Let me clear that. I'm going to put in 3 sine 3 theta. 3 sine 3 theta. I'm going to leave everything the same here. I'll close my parenthesis and I'm going to graph it. Okay. What you got there is what we call a 3-petal rose, essentially. And what kind of symmetries do you think it has, guys? Do you think it's symmetric around the x-axis or the y-axis?
I think it's the X.
Well, think about symmetry as when you fold it over on the axis, the sides meet. When you fold it over on the x-axis, the sides don't meet there. Where do they meet, guys? If it's across the y-axis, isn't it? Notice this one had a sign in it. It had a sign in it. It's got symmetry with respect to the y-axis because the y, or the sine of an angle or minus an angle, is the same across the y-axis.
What about the one on the bottom?
The one at the bottom, fold it over right there. You got that side matching that side. It all matches, doesn't it? It all folds together. This looks like a bunny rabbit, sort of. See those ears? All right, let me try to change one more thing, and then I want to look at something else because I want you to see if you see a pattern here. I'm gonna change that to 5. Anybody got a guess about what's gonna happen if I change it to 5?
5 petals.
Oh, she's a good guesser. Look at that. 5 petals. So if the number's odd, it looks like we get that many petals. So I mean, I could make this look. It gets messy after a while. Let's put in a 7. Let's see if we put in a 7 here. Let's see what it looks like then. I'll graph it. All right, I got 7 petals. Okay, it's still symmetric about the y-axis. What if I change it to an even number? Suppose I change this one to a 4. It looked like if we had an odd number, we had odd petals. If I changed it to a 4, and I did that, and I graphed it, ooh, if I change it to 4, how many petals do I get?
8.
Yeah. That makes me think, well, I don't get the 4 now, I get double the 4.
Yeah, I'll put in 10.
Did you put in 2?
10.
10? Whoa, 10's gonna be big. We'll try it. 10. 10.
It looked like a snowflake.
Okay, so 10 theta.
Yeah.
Okay, let's graph it. So it should have 20 petals on it, but I messed up the theta. Where'd my theta go? There it is right there. Graph it. Ah, okay. If you count them, guys, they're going to be 20. They're going to be 20. That would be darn near impossible to write in rectangular coordinate systems because and it's not hard to write in polar coordinate systems. So you're going to want to, this is really valuable depending on, what kind of curves you want to look at. And I want to tell you, let me tell you one more thing, and you can kind of look at this. You can look through some of the graphs here, but there's a page in your book, and that page is on, where'd it go here? It's got a nice little list of the kinds of things you can draw with polar coordinates. Oh, you know what?
So does only sign do that?
The sign, no, you know what? That's a really good question. Remember, these were symmetric with respect to the y-axis. Let's look at what happens when I change it to a cosine. So suppose I said 3, and I did cosine, and let's don't put so many petals on it, but let's put a how about 2? 2, if it's even, remember it gives me double the petals. So if I do that and I graph it, that's really nice, because what kind of symmetry is that one got, guys? Double symmetry. Perfect. It's got symmetry about the polar axis, this x-axis, and the y-axis right there. Now, that may not happen, of course, with an odd number. So, for example, if I went and I put in a 5 here, we'll see what happens, because it's doing 5 petals. Maybe we'll be able to see something different about the symmetry with cosine. If I graph that, now, I don't see. Do you see any symmetry at all there? I do see symmetry. What do you see there? These two match. If you cut it across this line, those two match, and each half of that matches. So this is symmetric about the horizontal axis, and it had a cosine in it. I think, didn't we put a cosine in it? Yep, had a cosine in it. Okay. So now, what if I said to you, let's find the area in one of those petals? Let's find the area in one of those petals. That's kind of what I want to look at later. Guys, tonight, work on your series stuff, and I'm going to have your Maclaurin series stuff back.
I think you're frozen.
Okay, I'm done. Bye.
Yo, is she frozen?
Yep. I'm frozen.